Imagine a celestial body so dense that a teaspoon of its material would weigh as much as an elephant on Earth. That's a white dwarf for you. These are not your average stars, but the remnants of stars that have exhausted their nuclear fuel. After burning for billions of years, these once gigantic stars collapse into a dense core, giving birth to a white dwarf. They are small, about the size of Earth, but their density is mind-boggling. Picture the mass of the Sun, packed into a space just a little larger than our own planet. These stellar remnants are not only fascinating because of their extreme density, but also due to their origins. They are, in essence, the final evolutionary stage of low to medium mass stars, making them an integral part of the cosmic life cycle. Stay tuned as we dive deeper into the fascinating world of these cosmic gems, the white dwarfs. White dwarfs weren't always tiny and incredibly dense. They had a magnificent past. Like a seasoned artist, the universe has a flair for dramatic transformations. One of its masterpieces is the creation of white dwarfs, a journey that starts with medium-sized stars much like our very own Sun. These stars in their prime are the epitome of celestial balance. The inward pull of gravity is perfectly offset by the outward push of energy produced by nuclear fusion in their cores. This fusion is the star's lifeblood, turning hydrogen into helium while radiating light and heat. But, as with all things, there comes a time when the star's hydrogen fuel begins to dwindle. As the hydrogen supply runs low, the star starts to fuse helium into heavier elements like carbon and oxygen. This shift marks the beginning of the star's transition into a red giant, a phase where it swells to a size hundreds of times larger than before. The red giant phase is a brief, albeit dramatic chapter in a star's life. It ends when the star exhausts its nuclear fuel completely. Without the outward push of fusion to counteract gravity, the star's outer layers are blown away into space, creating a beautiful gaseous nebula. Meanwhile, the core of the star, now free of its outer layers, collapses under its own gravity. It shrinks until it's about the size of Earth, but retains its mass, resulting in an object of incredible density. This is the birth of a white dwarf. Yet even as a white dwarf, the star's journey isn't over. It slowly cools and fades over billions of years, a phase known as the black dwarf stage. But that's a story for another day. So, the humble white dwarf once shone brightly like our Sun, before becoming the dense object it is today. Did you know that our universe is home to gigantic diamonds? Yes, you heard it right. As we venture further into the fascinating world of white dwarfs, we encounter a phenomenon that sounds almost too fantastical to be true. The cores of these celestial bodies, over billions of years, undergo a process that transforms them into what can essentially be described as massive diamonds. This process is known as crystallization. Let's delve a little deeper into this. As the white dwarf cools and ages, the carbon and oxygen atoms in its core start to move less and less. As the movement slows, these atoms begin to arrange themselves into a highly ordered pattern, a configuration we commonly refer to as a crystal structure. This is similar to how water molecules arrange themselves into a crystal pattern when they freeze to form ice. However, the transformation within a white dwarf is a much more extreme version of this process. The intense pressure and heat within the core force the carbon atoms to pack tightly together, creating a structure that is incredibly dense and hard. This is the same process that turns carbon into diamond here on Earth, but on a considerably larger scale. We're talking about a diamond that is hundreds or even thousands of kilometers in diameter. So, when we say that white dwarfs can turn into diamonds, we're not just waxing poetic. We're describing a real, albeit mind-boggling scientific phenomenon. Just imagine somewhere out there in the vastness of space, a diamond larger than our planet is quietly sparkling. And it's not just a single diamond star that exists. There are countless white dwarfs in the universe, and scientists believe that many, if not most, are on their way to becoming crystallized. So the next time you look up at the night sky, remember this: the twinkling stars you see may one day transform into the biggest diamonds you could ever imagine. So, somewhere out there in the cosmos, there's a diamond bigger than Earth, waiting to be discovered. White dwarfs are not just dense and glittery, they're also quite explosive. Let's delve into the thrilling role these celestial bodies play in Novae. Novae, or new stars, are not new stars at all, but rather a dramatic brightening of a star. The key player in this celestial spectacle, our very own white dwarf. This occurs when a white dwarf is locked in a close binary system with a companion star. Over time, the white dwarf's strong gravitational pull siphons off matter from its companion. This stolen matter, mostly hydrogen, accumulates on the white dwarf surface, forming a dense, hot shell. As the shell gets denser and hotter, the pressure at its base increases. After a certain pressure threshold is reached, the hydrogen starts to fuse into helium in a process called thermonuclear fusion, similar to what happens in the core of our Sun. This fusion releases a tremendous amount of energy, causing the surface of the white dwarf to explode. The resulting thermonuclear explosion is what we observe as a nova, a sudden brightening of the star that can increase its brightness up to 100,000 times. The white dwarf itself survives the explosion, and after a period of cooling, the process can start all over again, leading to recurrent novae. Interestingly, the term nova is somewhat of a misnomer. Ancient astronomers, observing these events, believed they were witnessing the birth of a new star. Hence, they named the phenomenon nova, Latin for new. But we now know that a nova is not the birth of a star, but rather a stellar tantrum of an old, dense white dwarf. Novas serve as a testament to the dynamism and vibrancy of our universe. Even stars that seem at the end of their life cycle, like white dwarfs, are capable of producing some of the most spectacular phenomena in the cosmos. Despite their size, white dwarfs certainly know how to put on a spectacular show. If you thought novae were impressive, wait till you hear about type Ia supernovae. Now let's delve into the extraordinary phenomena that are type Ia supernovae. You see, white dwarfs, despite their seemingly unimposing nature, can unleash an astronomical spectacle like no other. This occurs when a white dwarf undergoes a thermonuclear explosion, a process that leads to the formation of a type Ia supernova. But how does this happen? Well, it all starts when the mass of a white dwarf exceeds a critical limit, known as the Chandrasekhar limit. This limit, named after the Indian astrophysicist Subrahmanyan Chandrasekhar, is approximately 1.4 times the mass of our Sun. When a white dwarf's mass surpasses this limit, it can no longer support its own weight against the force of gravity, and it collapses. Most white dwarfs, however, don't reach this limit on their own. They need a helping hand, so to speak, and this usually comes in the form of a companion star. In a binary system, where two stars orbit each other, a white dwarf can slowly pull matter from its companion star. As it accumulates more and more matter, the white dwarf's mass steadily increases. When it finally crosses the Chandrasekhar limit, the immense pressure and temperature at the core ignite a runaway nuclear reaction. The white dwarf doesn't just burn, it explodes. This explosion releases an incredible amount of energy, outshining entire galaxies for brief periods of time. This is a type Ia supernova, one of the most luminous events in the universe. So while white dwarfs may seem unassuming at first glance, they hold within them the potential for a cosmic spectacle of unparalleled brilliance. They are more than just the remnants of dying stars. They are ticking time bombs, awaiting the moment to set the cosmos ablaze. So the unassuming white dwarf could be the progenitor of one of the most luminous events in the universe. The story of white dwarfs becomes even more intriguing when you bring exoplanets into the picture. Let's set the stage for this cosmic drama. Picture a white dwarf, a stellar relic, spinning slowly in the heart of a distant galaxy. Now imagine a tiny dot of light circling this stellar corpse. That tiny dot of light is an exoplanet. In recent years, astronomers have made some exciting discoveries. They've found exoplanets, planets outside our solar system, in orbit around white dwarfs. These findings are like striking gold for astronomers. Why? Because they open up a whole new avenue in the search for life beyond Earth. Consider this. The majority of stars in the universe will eventually end up as white dwarfs. So, if exoplanets can survive the violent death of their parent star and settle into a stable orbit around the resulting white dwarf, then these planets could potentially be home to life. But how can we detect these exoplanets around white dwarfs? It's quite a challenge. White dwarfs are small and faint, making their planets difficult to spot. But astronomers have a trick up their sleeve. They use a method called transit photometry. When a planet crosses in front of a star, it blocks some of the star's light. By observing these tiny dips in brightness, astronomers can infer the presence of a planet. The discovery of exoplanets around white dwarfs is not just about finding new worlds. It's about understanding the final stages of a star's life and how that impacts the planets around it. It's about understanding our own future. In about 5 billion years, our sun will also become a white dwarf. What will happen to Earth then? The quest for alien life is a thrilling journey of exploration and discovery. The recent findings of exoplanets around white dwarfs are important milestones in this journey, because who knows? The first signs of alien life might come from a planet orbiting a white dwarf. White dwarfs, the dense diamond-like remnants of stars, have truly fascinating stories to tell. As we've journeyed through the cosmos today, we've uncovered the mesmerizing world of these cosmic bodies, each with its unique tale of stellar transformation. We've learned how white dwarfs are the remnants of stars that have burned out and collapsed under their own gravity. They're the final evolutionary state of stars that are not massive enough to become neutron stars or black holes. These stars, once fiery hot, end their lives as a cool, dense white dwarf, a stark reminder of their past glory. We delved into the process of crystallization, a phenomenon that transforms white dwarfs into cosmic diamonds. The cores of these celestial bodies solidify over billions of years, forming a crystal lattice of oxygen and carbon atoms. This gives white dwarfs their diamond-like appearance, earning them the nickname diamond stars. We also explored the pivotal role white dwarfs play in Novae and type Ia supernovae. In a nova, a white dwarf draws material from a nearby companion star, causing a thermonuclear explosion that results in a sudden brightening of the star. In a type Ia supernova, a white dwarf accumulates so much mass that it triggers a catastrophic explosion, scattering its contents across the universe. These explosive events not only illuminate the cosmos, but also provide us with critical information about the universe's expansion rate and the nature of dark energy. Finally, we discussed how white dwarfs might host exoplanets, offering intriguing possibilities for understanding planetary survival in extreme conditions, and potentially even the search for extraterrestrial life. In conclusion, white dwarfs, these compact, dense remnants of stars, are far from being the dead objects they were once considered. They continue to shape the universe, playing a critical role in stellar evolution, cosmic explosions, and potentially exoplanet ecosystems. The next time you gaze at the night sky, remember the white dwarfs, these extraordinary objects that remind us of the past glory of stars and hold the potential to reveal the secrets of the universe. Did you enjoy our journey through the cosmos today? If you learned something new about the fascinating world of white dwarfs, then we'd love to hear from you. Why not give this video a like and share your thoughts in the comments below? We're always excited to hear your opinions and engage in stimulating discussions about the wonders of the universe. And if you haven't done so already, don't forget to subscribe to our channel and press the bell icon. This way, you won't miss out on any of our future explorations into the cosmos. We regularly upload content that delves into the mysteries of the universe, from the life cycles of stars to the endless possibilities of alien life. So, why keep all this cosmic knowledge to yourself? Share this video with your friends and family and take them along on this incredible journey through the universe. Remember, every star in the night sky has a story to tell, and we're here to help you listen. Thank you for joining us today, and as always, keep looking up.